Since before the days of Muybridge, there has always been a fascination with capturing human motion. In the beginning, we used rotoscoping to animate our storytelling culture, and today, motion capture has advanced in many different areas due to better quality and advances in technology. We conducted interviews at Face Space, a local motion capture production company. This is what we discovered.
Will you tell us a little bit about your optical motion capturing system?
So basically we track markers with optical cameras. They're cameras, and the markers are different than traditional markers in that they're LEDs.
Okay.
So each LED is blinking at a unique frequency, so it has a unique pattern. And so what that means is each marker has a unique ID. And that's different than traditional systems where they're actually reflective balls. And
Right.
it's easy for those markers to become confused with each other, which is called marker swapping.
Mm-hmm.
So with our system, we have no marker swapping. The other part of our system that's different is the cameras aren't really image cameras. They're not video cameras or standard image cameras. They're actually each camera has two 1D detectors. So basically we're looking at data in 1D, but when we get 3 detectors that see a LED, we triangulate to get a 3D point. And that makes the whole system much more efficient. So we can actually drive like 48 plus cameras on a single computer, where traditional systems would have a rack of computers for equivalent setup.
Okay, could you tell us a little bit about the process, like the planning process, how it works to do a motion capturing sequence?
It really depends on what you're doing, because our customers range from just universities that are doing research to people who are in the entertainment sector. So people are just doing research where they just put markers on maybe an arm or a limb, and they're just basically tracking that, looking at the 3D data and just analyzing it, using their own kind of software. Entertainment system would be something like this, where you have cameras all around, and someone will put on a motion capture suit with LEDs. You'll be lit up like a Christmas tree, and then you basically just start capturing that data, and then you can feed it in real time into animation programs there's third-party animation programs which basically take it onto a model or character, and then that's taken into something like Maya, where it's rendered out in a scene and set, and eventually into a game, film, or TV show.
Motion capturing has helped develop, like you said, a lot of research analysis and robotics, virtual training, surface scanning, etc. In the future, what do you think the applications for motion capturing will be?
One goal would be maybe to bring the price down so much and increase the volume so much that someone could have it as an input device for their own game, like in their own living room or something. So that's one, kind of like the Wii, but something more elaborate.
Right.
The other direction we're going, which is a kind of a different sector of our company, is the markerless. It's a different product. It does use high-speed video cameras, and it's a markerless approach where there's going to be applications where people cannot put markers on the target. For example, a lot of people are doing animal studies, basically neuroscience studies, and they're using animals. It's hard to put markers on like a rat's leg or something like that.
Right.
So,
or like a whale.
Right. So there are a lot of applications where markers can't be used.
Right.
And one other one, even in entertainment, is facial capture, where putting markers on the face is highly intrusive. So there is a lot of movement in trying to do a markerless-based facial capture for animation.
Okay, great.
We're just seeing the coarse scale geometry here, but they basically created a digital puppet of her where you can pull on these various strings and it actually moves her face in ways that are completely consistent with the scans that we took. In addition to the coarse scale geometry, they also used all of that detail to create a set of what are called displacement maps that animate as well. These are the displacement maps here, and you can see those different wrinkles actually show up as she animates. So the next process was then to animate her. We actually used one of her own performances to provide the source data. So by analyzing this video with computer vision techniques, they were able to drive the facial rig with the computer-generated performance. So what you're going to see now, after this, is a completely photoreal digital face. We can turn the volume up a little bit if that's available.
Imagemetrics is a markerless, performance-driven animation company. We specialize in high-quality facial animation for video games and films. Imagemetrics is a markerless, performance-driven animation company. We specialize in high-quality facial animation for video games and films.
So if we break that down into layers, here's that diffuse component we saw on the first slide. Here's the specular component animating. You can see all the wrinkles happening there. And there's the underlying wireframe mesh. And that's Emily herself.
With novelties such as one-dimensional tracking used by FaceSpace and new interactive layers as described by Paul Debevec, future discoveries will make motion capture more accessible and more lifelike.